Okay, so this is your rates homework booklet. The first question is an experiment whereby someone is seeing and adding sodium thiosulfate to dilute acid and seeing how long it takes for the cross to disappear. Okay, and we've got different temperatures of the acid. First thing you have to do is plot your results on the graph, okay, which we obviously can't do here. And then it says describe the trend in the results. As the temperature increases, the time decreases at a decreasing rate. Okay, so as the temperature increases, the time is decreasing. So you can see that, and it's a decreasing rate because it's kind of curving down. The second student carried out the same experiment using a higher concentration. Okay, this is where it gets a little bit confusing with these types of graphs, okay, because you naturally want to just add one above, okay, but by adding one above, you're saying that when you add a higher concentration, it actually takes longer. Looking at the time here, so time taken for cross to disappear would actually take longer at the temperatures, okay? We know by adding a higher concentration, it should be a lower time because you'll have more particles, they're more likely to collide, okay? So you need to add a curve underneath, okay? Which is a bit confusing because the graph is not technically, but it looks the wrong way around. Then it goes on to say, another student suggested using a light sensor and a data logger to study the reaction times. Describe one advantage of using the light sensor. It would measure how much light can pass through the mixture, less light, a darker mixture, so it would be more accurate on the colour change. It doesn't just rely on the naked eye. Rebecca was asked to investigate the pH, how the pH changed during a reaction using hydrochloric acid and potassium hydroxide. She slowly added potassium hydroxide solution to 25 centimetres cubed of dilute hydrochloric acid and recorded the pH using pH sensor. The results are shown in the graph below. Use the graph to give the pH of the hydrochloric acid before adding. Okay, so before we added it, so we can see here minimal 0 of the volume of potassium hydroxide and the pH is 1. The volume of potassium hydroxide required to neutralise. Okay, so neutralise is when your pH is 7. So draw a line down, it's roughly 24 centimetres cubed. Rebecca would also investigate the pH change using a universal indicator. State the colour the universal indicator goes when it is neutral, that would be green. Give one advantage of using a pH sensor to investigate changes in pH, more accurate, and it gives an exact pH, whereas this would just give a rough pH. You could get to a higher degree of resolution because you can have more decimal places. Places. So the next question then is an experiment whereby they are putting magnesium into copper sulfate, and there's a large method that if you wanted to read you can pause the screen, but it would be on a sheet. And then there is different masses of magnesium added, different pupils, and how much temperature there was for each mass. Okay, so the first question then is asking us to circulate the nominal results, not using calculating one of the means. Okay, straight away it stands out like a sore thumb is this one here, 3, because that would never give you a mean of 9, so they've obviously not included that in their results. Suggest one possible case for the anonymous results: incorrect mass of magnesium added, or it might be that he read the thermometer wrong. Next thing you had to do was plot mean temperature rise against the mass of magnesium added. You were quite lucky by where they gave you all your axes labelled, and then it said start your origin at 0, so that means your curve or line had to go through, okay? When they say a line of best fit, it can be a curve, okay? So don't think it desperately has to be a line. This one just stated that it had to go through the 0, 0 point. State where the line of best fit must be drawn from the origin so we can use it to calculate our rate. Use the graph to find the smallest mass of magnesium added to react all of the copper sulfate. It is 0.8 because it levelled off and all reacted the same afterwards. They had the same temperature rise afterwards. Okay, again, another experiment whereby this time they've got sodium hydroxide in a beaker and they are going to add some dilute hydrochloric acid. Okay, from the data, state the volume of acid where the temperature readings appear to be incorrect. Okay, so you've just got to look through it. And I picked 30 because the values aren't repeatable. They're nowhere near each other. It also doesn't seem to fit the trend. That value there seems to be really high in terms of the trend going along. Okay. Next thing you had to do was plot mean temperature and draw a suitable line. Again, this is a curve up and then a curve back down. Okay. Again, it doesn't have to be a straight line. Okay. Use your graph to state why the incorrect temperature readings identified in part A might not have been first noticed by the pupil. It still kind of fits into the trend. The graph still shows an increase in rate to a point. Explain and describe the shape of the graph in relation to chemical change taking place. So the rate of reaction increases as the volume of acid increases until 50 centimetres cubed, when the rate slows down unless there is less temperature increase. Finally, this is quite a complicated question to look at. Okay, so it says graph A shows the volume of carbon dioxide formed during a reaction between excess marble chips, calcium carbonate, and dilute hydrochloric acid. Okay. On the same graph, sketch carefully the graph that will be obtained by replacing equal volumes of hydrochloric acid with double the concentration with marble chips still in excess. Okay, you aren't doubling the volume, you are just doubling the concentration. So you're still going to end up with the same amount of carbon dioxide being produced because you're doubling the concentration, not the volume, but it will happen quicker. Okay, so I've put my line upwards. I've made a bit of a mistake there. It has to be a really smooth line. Okay, so be really careful of that. So it has to be above because it's double the concentration, okay, but it isn't double the volume, so it's not going up above it. It still needs to end up at the same end point. And then it says, on the same graph, sketch graph will be obtained if the marble chips were ground into powder and reacted with the same volume and concentration of acid produced in graph A. Again, they're ground into powder, it's going to react quicker, but no more carbon dioxide is going to be produced. So again, a line next to it, okay? Explain why your answer to part I using particle theory. Larger surface area increases places where reactant particles collide, increase collisions, increase successful collisions.